Hello and welcome to our fourth Automation Village virtual trade show. My name is Chris Little, and this is our follow-up to our monthly virtual trade show experience that we live stream on YouTube every month for the past 4 months. And thank you everyone for tuning in today. It is a beautiful day. I hope it's a beautiful day where you are. And thank you for missing it on our behalf. And as we go around and talk to our various different experts who will be going into more detail on some of the topics that we learned about in the trade show, we'll find out how the weather is there too all over the world. So coming up next in this hour, first of all, here, if you've tuned into the Water Wastewater stream, you'll be talking to Phoenix Contact. And they'll be talking about secure remote connections for water and wastewater systems. At the same time, over in the design, operations, and planning stream, you can listen to FlowWatch while they talk about embracing modern data management software. And in the digital connectivity stream, we have BRAAS, IT topics which are relevant on the factory floor. So up next, we have Don Dickinson and Miriam Coladonato from Phoenix Contact. Hi, are you guys there?
Hello, Chris.
Hey, Chris.
I love your backgrounds. Although it looks like you're both sitting in the same chair at the same time. This can't be possible. So
we miss the office.
Yes.
Well, especially since I'm in North Carolina and Miriam is in California.
California, yeah.
That would be a big fair.
So how's the weather in California?
It always starts a little bit overcast in the morning, so it's a little early here. Still overcast, but most of the days after that, it's pretty beautiful and sunny.
Oh yeah, we made you get up early for this. Thank you.
Mm-hmm.
And,
no. No problem.
And Don, how about you? How's the weather other than beautiful?
It's kind of back and forth, lots of rain, but looking forward to some sunny days here over the Father's Day weekend.
Oh yes, that's great. Okay, well, without too much further ado, why don't you guys share your screen, because you've got a slideshow all queued up. And before we begin, why don't, Miriam, while you're bringing up the slideshow, you just steal it from me. Well done. Nicely done. Don, why don't you tell us a little bit, you wear a lot of hats with not only Phoenix Contact, but with the industry in general. Why don't you tell us a little bit about what you do?
Well, in addition to my role at Phoenix Contact as a business development manager for the water sector, I participate in lots of industry organizations, whether that's AWWA, it could be WEF, or with ISA, which is the home of automation for the industry. I'm serving as the director of the Water and Wastewater Industries Division. So if you are into automation and you're into our industry, please join ISA and join our division.
That's great. And Miriam, how about you? Tell us about what you do with Phoenix Contact.
Yeah, definitely. So I am a lead product marketing specialist, and day to day, I do have a product responsibility that we will be, mentioning briefly today, but I'm also kind of in charge of overall networking and security message, the materials, helping the entire organization on how to present a holistic security approach. And that's kind of like what I, preach every day to, you guys, to customers, our entire sales organization, because we are not, when we are not just used to that type of technical knowledge or technical conversations or technical sales. And even at the customer level, it's hard for them to also understand or grasp some of the technology. So it's easy, to create some type of message that they can understand, because we're kind of just tying more IT into OT, OT into IT systems. So it becomes very complicated at some point. So I help them guide those conversations with different tools.
That sounds great. So at this point, I will happily hop off and we'll turn off our cameras and I'll hand things over to you.
Very good. Thanks, Chris.
Thank you.
Again, thanks for the opportunity to present today and contribute to the dialogue on cybersecurity. And always a reminder is that cybersecurity is not our goal. Our end goal is protecting critical infrastructure and ensuring the availability and reliability of critical water systems. It's the backbone of our country. And I'm going to get into some conversation here about this topic, about why we need secure remote communications. And let me preface my comments here with this. Generally, in our industry, which is a decentralized infrastructure, we realize that remote communications are essential. Now, we normally think in the context of SCADA, but I wanted to go really outside the boundaries of SCADA, because what we see happening in our industry today, especially with the advent of the industrial Internet of Things, is there's tremendous amount of data that's being collected well outside of the classic SCADA scheme. That data is being used for process monitoring and control. Well, the IIoT, or you might call it smart water, we're really looking at data for many other applications, such as asset management or process efficiencies that could come through our SCADA system, but many times we're seeing all these alternative channels of communications and data flow that's breaking down our traditional hierarchies and of our control architecture. So with that in mind, let's talk why any type of remote communication needs to be secure and what we might want to do with that. Again, I'll emphasize the points about why we even need it to begin with in our classic sense, and that is we wanted to maintain situational awareness. We need to know what's going on. That's either monitoring our process, it could be monitoring the status of critical alarms that could have an impact in regulatory compliance. The one that I see most often today that's kind of outside the realm of SCADA is the need for someone to be coming into a system to provide remote support and diagnostics. That could be a trusted third party like a system integrator, could be an OEM that needs access to a piece of equipment for a service level agreement requirement. And then thirdly, as we see here, it ties into the whole conversation about emergency response, disaster recovery, because that is one of the key conversations that we're having now, especially on the water side of our industry, because of some legislation that came into place in 2018. And if we move on to our next slide, if you're not familiar with it, let me give you a quick overview of AWIA, that is America's Water Infrastructure Act of 2018. Now, this is a very broad piece of legislation, but in Section 2013, we see that there are some very specific requirements for community water systems or drinking water utilities. So the first requirement that comes up under AWIA is the need to establish risk and resilience assessments. So we're going to conduct those and certify those. We're looking at risks that are posed to our drinking water utilities, and we're looking at resilience of these systems. And following up on your risk assessment and resilience assessment, we also, utilities have to complete an emergency response plan within 6 months. And here's what's really different. There's been quite a number of requirements in the past around vulnerability studies. What's different now with the AWIA is that the risk and resilience assessments and emergency response plans are now have to be reviewed and updated every 5 years. So this is something that's going to be going on for the future. It is something that, even though it applies only to drinking water utilities presently, I think it's a safe statement to say that the best practices and requirements that the drinking water utilities are following will follow with the wastewater treatment facilities as well. So let me just give you a quick overview of what some of the verbiage is in AWIA and how that applies to our conversation for today. By the way, there are specific deadlines that are required based upon the size of your utility for both doing your risk and resilience assessment and your emergency response plan. And if you're looking here at the chart before you, you see that for utilities serving more than 100,000 customers, their initial deadline for their RAA or rather RRA, was March the 31st. So some of the largest utilities in our country have already gotten into this process. You see the next deadline that's coming up will be for their emergency response plans, which is September the 30th. So there's already action going on to meet the requirements for AWIA, and you see smaller utilities will be complying with deadlines staggered off towards the end of next year. But getting into the verbiage that we have as far as what AWIA actually requires, I'd like to highlight a couple of key definitions because this really comes into play. Resilience, that is the key word for our industry today. And you see the definition as it's laid out in the legislation. I'll give you a simpler one. Resilience is how big of a hit can you take and how quickly can you recover. The next key definition there talks about hazards. And this comes up in the conversation because we're talking about all hazards, whether that is a natural hazard or a malevolent one. Obviously, we know what a natural hazard is, but the legislation does spell out some of these definitions so that we understand exactly what it is that we're trying to address. In this next slide, we see that there are some details around the risk and resilience assessment. And let's hit this first bullet point here. And the things that I've put in bold are relevant to our conversation today. We want to be able to assess the risk to a system from both a malevolent act, something that is intended, as well as natural hazards. Again, the goal here is protection of critical infrastructure. And whether it is a natural act or an intended act by a threat actor, we want to make sure that the resilience of the system can hold up to that. Our next point here is we're really looking at the resilience of a variety of things, but I've highlighted these key features. We're looking at the resilience of electronic, computer, or automated systems that are controlling these processes, and that includes the security of such systems. So for the very first time, we've got some real specific requirements around how we're doing our, we'll call them SCADA systems or process control systems, whatever the term we use, but that's in play now. We're also looking at the monitoring practices of the system. How are we being able to determine that something's going on, and how do we respond to that? In this next slide, we'll continue with some of the key points that come up. You notice they're not in bold, so I just want to put that in because that is some of the real verbiage that goes into the legislation. Not important for this conversation, but I thought it might be good for you to know. Moving on to our emergency response plans. What's included there? You see some keywords there. It could be either strategies, resources, the equipment, whatever that may be, but we're looking, how do all these things play into the resiliency of your system? And for the first time in legislation, it's looking at security, both physical security and cybersecurity. So that's why I think this conversation today is relevant. We now have specific directives for the first time in our industry that relates around cybersecurity and what that means for drinking water utilities. And then you notice another point here is about how we can identify equipment that can be used in the event of some type of hazard taking place there. And on our next slide, and again, here's some key ones here, is that what are the actions or procedures or the equipment that we can use to significantly lessen the impact? What they're really saying is, how do we be able to detect that something's going on? How do we respond to something so that we can mitigate that event as early and as quickly as possible to minimize the damage to our systems here? And then finally, what can we use in the detection of something going on that could impact the resiliency of our system and that can threaten the security of critical systems? Now, that's verbiage from legislation. That's very big picture. That may or may not mean much to any of us. And I thought a better way to start narrowing down our conversation is to take a look at the NIST cybersecurity framework. That really has been driving the conversation on cybersecurity for critical infrastructure for the last several years. And I like the core portion of the framework because it really helps define what are the key areas of cybersecurity that we need to be focusing on. So as we define the tasks ahead of us to reach specific goals, these 5 categories, which are identify, protect, detect, respond, and recover. Now, I think as Miriam will tell you, nearly all of the conversation that goes on with cybersecurity focuses on that protection side, which makes sense, does it not? We're trying to prevent something from happening. But when you're dealing with critical infrastructure, what we know is that things do happen. Again, whether that's a natural hazard that is having an impact on our system or an intended attack. Either way, we've got to understand how do we detect what's going on, how do we respond, and more importantly, how do we move to that recovery process? And I think the key message that I'd like for you to leave with today is we've got to start thinking about going beyond protection and going into the other phases here, because that really is what defines resiliency of our critical infrastructure, drinking water and wastewater treatment. So Miriam, I've been talking about some very big picture topics here, starting to bring that down into a few more defined categories around cybersecurity. But I know that in your role, you work with the nuts and bolts. You get into the real details. And that was really the heart of our conversation today, is saying, look, we know we've got some directives now. We know that there are things we need to do, but we need some specific guidance, whether that's best practices or different approaches, things that we know we're going to be implementing to not just reach a level of cybersecurity, but also a high level of resiliency. So why don't you share some of the things that you share with our clients every day in terms of how to raise our security profile, reduce an attack surface, and improve resiliency of critical systems?
Thanks for the intro, Don. And yes, you definitely have more of the key takeaway for the specific infrastructure when I normally have more of a holistic general overview of cybersecurity overall across industry. And to be honest with you, it all relates pretty closely to each other. It's just a different process. It's a different PLC, it's a different protocol. But then let me take your general approach, and I'm going to make it a little bit more specific on things that you can be doing or things that you need to be start writing down on your to-do list to make yourself a little bit more secure, to start applying security controls. Cybersecurity for industrial control systems, it's not a one thing and done, right? And if it's in depth, it is not a new term for implementing cybersecurity on operational networks. A lot of this also comes together with risk management, the people and the collaboration that is working, the documents that kind of highlight policies and procedures, and then we're going to be jumping into more detail into the technologies. So let's move ahead with that. The first thing is the human behavior. You are only as strong as your weakest link. Humans are just click crazy. We are the weakest cybersecurity link on any organization. And however, I still consider it the easiest one to implement or to modify or implement, because the only thing at this point that you need to do is create a security culture, a cybersecurity culture, either by starting with seminars or training that help everybody be a little bit more safe on the internet, and then dedicate it a little bit more into security training, depending on the role and things that they touch within the organization. So that is a simple thing that you can start modifying for the security awareness. After that, it kind of ties back to also the human behavior is the collaboration, right? What I call the collaboration. Moving on into cybersecurity and the future of cybersecurity, you're going to have to collaborate with a lot of partners, internally and externally. You might not have all the resources. You might have some resources available. So that's why what I said right there, if you want to go fast, go alone. So take what you have right now and put it into place following the applications that I'm going to be talking about. However, if you want to go a little bit further and prepare for the future and be more resilient within your network, then you're going to have to work with your IT department. You're going to have to work with system integrators because there's always lacks of resources, no matter the industry. The next thing is always going to be the documents, right? This is probably one of the most, what I consider to be the most boring. This is where you start talking about, cybersecurity, incident management response that you mentioned. But how do we start? How to create policies and procedures around the operational side? And you can start with something that you already have. That would be for example, your enterprise ones. Make sure you're familiar with them and how to apply them down. And this is where you also start talking about the resilience and the NIST cybersecurity framework that you just mentioned, and even more detail, IEC 62443, which talks about the practice of actually implementing cybersecurity on operational sites. Technology. So when we talk cybersecurity, this is where we spend most of our time, most of our resources. Everything we do around the first steps in cybersecurity, this is where we focus on. This is where we're going to be focusing most of our time. However, my message here is exactly what it says. You have the technology that it is working out there. However, it is a two-edged sword. It can bring many benefits, and that's why we want it, right? That's the idea of IIoT. We have the technology, we have the devices that give us the data, but you need to properly use that technology, and especially the security controls within the different technologies, to be able to avoid any type of disaster. We are going to be talking about the technology, Phoenix contact technology in different layers, multiple levels within a plant or the remote connectivity in the next coming slides. And the last one is the risks, right? How to manage risks. Creating a defense in depth strategy might sound overwhelming at first, but it doesn't have to be. So my message is keep calm and, just wash your hands. And what do I mean with this? Before pandemic, we always kind of knew, right, that we had to wash our hands regularly, but now we're just doing it more and more. And if you're not doing it more and more, it's a risk you're willing to take. It's exactly what risk management has to do. So having all the information around your plant, around your vulnerabilities, around your devices, and applying security controls around maybe your more vulnerable areas, and deciding to manage the risks on the areas that you're not, that is taking the risk management approach. It's like, where are my most vulnerable areas? Let's secure those, and this will manage somehow else. Okay, so just simply reducing the risks of getting sick or of getting your network sick using a risk management approach. Now let's get into the nits and grits of the information of what I wanted to present. Defense in depth, a defense in depth strategy for water, wastewater plants. What can you do right now with things or technology that you might or might not already have? And if you don't have it, we have it. And what can we do for you? What can Phoenix Contact really do for you? Besides, offering this piece of information that we have here. So we will move in and kind of just imagine the picture. We will move in from layer to layer, from inside of the fence, right? So inside of the plant with a basic defense in depth, and then move out to that remote site to show the security best practices that you need to be using to connect those remote sites back into your SCADA. So the first one that I always wanted to start is like, well, you have within and close enough, it's your panels, right? You have your panels. How do you talk about panel security? This jumps into one of the points that Don mentioned. It could be the part of physical security, or it could be, you know, of a remote site. And panels are located on both. It could be at the inside plant or close to the SCADA, or it could be a remote panel. If you do have, and this is probably one of the most switches used within the industry, if you do have an unmanaged switch, this is a low cost application or solution that you can start applying. However, there's no real active monitoring on this type of scenario. So if you take a look here, we have an unmanaged switch that's a Phoenix Contact SFN. I think it's a 5-port. And we do have what is called a port block or a port lock. Yes, it's nothing more than a physical port lock that will not allow you to just plug in a cable or take that specific cable out, Ethernet cable, I mean. But if again, the negative portion of this is the no monitoring. So anybody can really come into this panel and get in. So that would be the first step, getting in. And then the second would be grab some type of screwdriver or tool to be able to kind of remove all that. If you get into the panel and that cable was pulled broken, you know somebody tried to just hatch it, break it. This specific port lock is only matched for our Phoenix Contact unmanaged switches. However, that doesn't mean that we don't have other low-cost solutions. And physically, for cybersecurity, it checks a box, okay? It checks a box for security network. If you take a look at the other physical key, it's more fit for the cable. So the cable will actually go through that on the bottom left corner. And it won't allow you to unplug or just move, you know, the what I call the cable lock, you know, the cable helper, to unplug it and plug it back in. Again, it is not monitoring, and it doesn't matter what brand of device or what devices you have in there. It's more of somebody has to have a key to let you in the panel. Somebody has to, you know, have a secondary key to let you in the specific port if you want, you know, an engineer or a technician to be able to connect physically to that specific panel, which I personally don't see the need for that. Now, moving on, yes, you might have managed switches and you don't need, this is where the meat of the information of cybersecurity starts. Monitoring your network starts with a managed switch. Well, putting the same example, at this point, you could use the embedded security features that all or the majority of managed switches already have, that is enable or disable the ports that you are using or not using. So if anybody actually gets into that cabinet, you can, you know, just have the ports disabled and nobody will be able to log or connect to that specific switch. And the additional security to that, because you can easily say, well, you can unplug the other, you know, 3 in the case of this specific picture. You can unplug any of the devices and just plug your laptop in or your device in. And the additional security layer at that point is you actually have port security for Mac, right? So you can tell that switch that only this specific MAC address is allowed to talk through this port 3, which is great. And if that happens, the great thing about managed switches, it's the monitoring. You can have that switch sending logs, sending network data. Hey, somebody just unplugged this and plug a different MAC address and send it to some type of security SCADA monitoring. That's where it's going to give you all of the alarms and all of the things. User restrictions. So network devices such as this one also support radius authentication. And to not get into details, it's nothing more than, you know, when your IT organization allows you to log into things on intranet, extranet, Windows, all within saying one username and password that they manage, it's exactly the same thing. Our devices, industrial devices, can talk to those authentication servers, and you can use your same login across the entire operational site too. If you need to manage the switches, if you need to manage devices or allow to manage devices inside, you can also do that. Now, different layer, and this is something that technically doesn't fit as much within this specific industry, but I always like to talk about it because there is sometimes very remote sites. Or maybe, you know, you want to monitor the panel. This is what we call a PSR switch. It's nothing more than a safety sensor that will give you, you know, a digital signal 1s and 0 for opening and closing a door, mostly used for safety applications. However, I always like to talk about it because if you do have a remote panel, right, that you want to connect in, and somebody, you know, kids driving a truck in the middle of nowhere want to get in the panel just because they're being funny, this is something that if you do not have monitoring, active monitoring on that remote panel for the specific gate, right, for the specific opening, then you won't really know. This will be something low cost and some basic active monitoring that will send a signal as soon as that cabinet is open. Even if you do have an engineer out there that is going to perform some local troubleshooting and support, perfect, you were already planned for it. But if you don't have anything planned, then you will get that alarm saying, hey, this cabinet was open, you want to mind not come check it out. And then additionally, and going a little bit kind of like ahead, it's video surveillance, right? So this could apply for local, you know, local security at the plant level, local inside the fence security. And even if you do want to move to the remote sites, have some type of visual and security system on the remote side, we do have things like this, that it is called what we call the camera ready box. It is a little bit of a higher cost because it is kind of like a solution, as you can see, and it does have it provides you already for connection for 4 PoE ports. So all the PoE cameras, outdoor PoE cameras that you might already have there, you only kind of put it in, it's ready to go to just install. It has the power, and also give you a couple ports for copper or fiber as a whole. And it does have a managed PoE switch, so you can add additional security within that specific switch. Now, we talked about the specific panel security and a couple of the things that you should or could be doing as of right now. What else can we do, and what other technologies are we using? How do we connect those camera ready boxes? How do we connect that safety sensor? How do we connect all of those devices that will send us that active monitoring data back into our central SCADA or the specific PLC or the specific process data back into our central SCADA or our security, what I want to call security operating SCADA site, right? And one of these technologies that is used the most is WLAN technology, right? Wireless LAN. It's nothing more than Wi-Fi. It exists on an industrial side. However, the range, it fits within, you know, about 1,000 feet. So you have to kind of think about more like in plant type of thing. The different things that you could do to apply cybersecurity within some type of WLAN network, it is the SSID for invisibility. You can just grab the SSID of the access point and maybe not broadcast it. You can just hide it, and you configure the clients. The clients could be other panels or even users with iPads or tablets that are driving around the plant, and they need to connect to the specific assets without the need to really getting down of the car, and going to the panel and opening the panel, et cetera, et cetera. They can all do it through their specific, laptop or iPad, as shown in the specific image. And it doesn't have to be, so besides you're hiding the SSID, you can also add some type of MAC-based filtering for the specific host and the clients connecting to the network. So at this point, if you're only allowing internal employees, internal operators to drive around the plant with iPads or laptops, you own those specific devices. You could have a database of those MAC addresses and put them in the specific, and putting in as a MAC access rule and say, only allow these devices with this MAC addresses to be able to connect to the SSID using the password. And of course, after that, everything is nothing more than security best practices for Wi-Fi. like, make sure you're using encryption higher than WPA2, and password management. We already know, use a long and complicated password with numbers and special characters. Additionally, that kind of jumps into Don's point for resiliency, is some devices within the WLAN actually support mesh. Mesh wireless is just giving resiliency to the network. So if one of those settings or one of those connections go down, you can actually just, or the specific device is just connected as a mesh, it will do some type of redundancy and self-healing within the network. You will be able to find the data will be able to find their path back to SCADA or the other way around, thanks to this mesh technology. Now, the additional security that you can apply within this specific type of application is a firewall. Think about it. Yes, you could say, okay, only the laptop or devices are allowed to go in, but you're not able still to filter the specific layer of data. So what a firewall is doing is actually filtering what that specific user can or cannot do through the medium that will be the wireless infrastructure. So you can put a local firewall right in front of those wireless clients and just be able to filter data. So if you have operators that are only allowed to read, the specific sensor data, or they are allowed to open their laptops and connect to the PLC and change and update the firmware and change configuration profiles, that's perfect. You can tell them or allow them to do all of that depending on their role and what it's really allowed, what they really should be doing or not allow them to be doing. You could take it an additional level, and besides the encryption that you have for the communications on the mesh side, you could have use the firewalls that you already have. They have embedded VPNs, so you could have just a VPN that it is local into your SCADA. Just additional layers. So at this point, you'll have the mesh infrastructure, the medium that will connect those remote sites back to SCADA. Even though there is all local, you can still add the VPN security layer at this point. Now, other technologies that gets used on the industry a lot is trusted wireless. And again, it kind of goes very close to the just standard WLAN. It just goes a little bit further. The range is up to 20 miles. We do have ways that you can have flexible network structures, like you can have a point-to-point, star, or repeater. The idea is to connect those more remote sites with some type of radio, trusted wireless radios. It is self-organizes and self-healing, which brings to the point of resiliency. So if one radio communication goes down, the other one actually allows you to kind of pick it up because it's just going to go around it. And it is hot swappable. So our radio line modules that are you can see right here are actually pretty easy to configure with a thumb. Set up the channel and kind of just press the button and they're connecting. It is using an encryption of 128-bit AES. It is proprietary frequency hopping technology, or you can actually get a unique ID for that mesh or for that communication in the wireless via a config stick, what we call a conf stick. It's an additional part number. You will plug it in on all of your devices, and they will just have that unique way or a unique network ID to connect and to talk to each other. You could technically, at this point, if you do have trusted wireless Ethernet communication, you could follow the same example I just mentioned before and have the radios, the wireless radios, being nothing more than the medium. You can still give them the encryption. You still have that wireless encryption and still put an additional layer of defense that it is a firewall and the VPN. So using the VPN for device-to-device communication back to plant, and the firewall for any type of traffic that it is malicious that was able to get in at the radio level, right, at that specific frequency hopping spectrum, then you have the firewall protecting your devices at that point. And again, this range goes to more devices that are sitting up until the 20 20 miles. Now, this is more of a global scale. Cell phones. This is an example of alarms and what is going on a very remote sites that are, that are not happening. We're talking about more of our cellular modems called the TCM guards, and they can actually, you can tie them to send a text message and see, and read some of the data. It could be secure to allow them a list for phone numbers, so you can actually reply back and say, hey, open that pump for valve 1. Security comes at only some numbers or phone numbers can be allowed to send those control capabilities. You can also use the VPN, right, for the cellular side to be able to come in. All of these working together. And you can even use the text messages capability to enable and disable the VPN of those remote sites. So if you don't want to have it enabled at all times, you can always have it disabled, send a text message, hey, turn on my VPN, turn it on, send the data back to SCADA, turn it back off whenever it's needed. Now, this is what we call machine-to-machine communication. Now, what happens when you need users that they need to connect in, that they need to troubleshoot, either system integrators or vendors that need to come into those remote sites? You can use a service like the MGuard Secure Cloud that we have to offer. It's very nice and granular because it provides you the configuration, the tunnel, a unique encryption, a unique certificate for your specific account. And then kind of moving on after that, you can have user restrictions. So only the system integrators will be able to see the specific equipment that they provided for me. And you can be even granular to the device level. They can only see the specific device that I want them to see, which is pretty nice. It makes it a little bit more easy to manage and automate it. Now, network resiliency, right? Network redundancy. How do you do network redundancy within this type of applications with the really remote sites? They might be within wireless range, like Ethernet wireless range, but I also want redundancy. You could use the same cellular modem with the radio or with trusted wireless radios. As you can see on the device, on the MGuard device right there, which is the red line across, that has a couple interfaces, and you can see what it has. A WAN interface that will be, for example, your wireless interface. That's what it's going to go and send the VPN back to SCADA at that point. So all the VPNs, either to SCADA or to the remote user, will be connecting through there. But if that radio has some type of miscommunication, something happens, then the cellular connection will be allowed to kind of just use off redundancy and backup, and use the same backup for the cellular network back into your SCADA, back into your plant. Again, increasing resiliency within that remote site. Now, something nice that we do have to offer, it's actually pretty popular within everybody in the industry, and customer system integrators. We use it a lot ourselves when we need remote support. This is what we call the M2M box, and remote connectivity in a box is ready to ship. It's one part number, depending on the application, depending on what to do. It's, the different devices. The only thing you have to do at this point, you can grab the MGuard Secure Cloud configuration, put it on the device, and ship it out to your end customer. They just have to connect in. It will use the cellular network to connect, and that's it. And you can get in as a user, as a technician, to be able to troubleshoot and support that specific machine. When you're done with that support or immediate support that you need, I see, I saw it used a lot on this specific stay-at-home orders. Then they will just ship it back, and that's it. That's your kind of your M2M box for remote connectivity. And now, the last thing to keep in mind is that you're not alone. You have trusted partners that you can work with. And even at the vendor side, like us, we can work with your trusted partners. We can work directly with you for all your industrial security and networking services. We do have a group of engineering services team that can do different tasks like evaluation and planning, implementations and documentations, following security standards, maintenance and support, awareness seminar, and product training, depending on everything, depending on the exact your requirements and applications. Now, to close my point is remote connectivity in water wastewater is not a new term. Because of the nature of the decentralized infrastructure, we always have to find ways to bring the data in. Now, time has passed. We need to make sure we make those connections more secure and more reliable, because that's it. Are we making this securely? The entire operation is depending on it. And lastly, to close this session, this year has showed us that things happen. They can easily disrupt the ways we run our life and businesses, and there is no real way to control them. However, they can be in management. Therefore, my point that stays, control what you can with the ideas that I just provide you, but manage what you can. Active monitoring is that part of the manage what you can. Risk management is that part of manage what you can. Do not let any malicious act or incident affect the availability, reliability, or the overall resonance of your network. So take security as a holistic approach. Follow the writing guidelines provided, train employees, and collaborate internally to apply all these multiple layers of defense. Know that you're not alone. Security always sounds challenging, but it doesn't have to be. You can count with your partners. You can count with Phoenix Contact engineers and technology experts for your secure and remote connectivity needs. With that said,
well done. That's great. You really packed a lot in there and made it really clear. I appreciate that.
Yeah.
That's not an easy thing to do. So we have one question that I see Dawn answered on the live chat. If anybody has any more questions, just type them in either in the Q&A section or in the chat section, and we'll get those answered for you. I had a quick question. So the do you say AWIA or AWIA?
I think the popular term is AWIA for
AWIA.
America's Water Infrastructure Act. Yes.
So if I'm a superintendent of a water utility who thinks that maybe I need to start thinking about this a lot more, where can you go to actually download that act? And is that the first move? Is that act in a form that people could read it and take away an actionable set of recommendations?
Chris, it's a piece of legislation. It does nothing more than obligate someone to doing something.
Right.
Now, so with that said, there's lots of conversation that's going on in the industry. So the first thing, and by the way, there's a lot of tools, and the beginning point is starting to look at the risk assessment methodology that will be used for the risk and resilience assessment. Now, what the legislation says is this: we're not telling you to use any particular tools on how to do that. And by the way, these are self-certifications. So they're basically telling you these are some requirements that are a bit vague, that we're not going to tell you how to do it, but yet you're responsible for making that happen. So luckily, the industry, whether that's AWWA, they have some great resources, starting with the J100 standard. So that is the risk assessment methodology. I'm not saying that it's the most exhaustive or the best one that's out there for assessing risk, but it was developed specifically for our industry. And speaking for AWWA, I highly recommend that you start with some of the tools that they've put in place. I'll also put in a plug for ISA, because all of these efforts at some point look for some type of standard or methodology. And when you start getting into the world of automation, I still consider the ISA IEC 62443, standard as being the very best for critical infrastructure cybersecurity. But Chris, I actually have a question I want to ask of Miriam along these very lines, if I may.
Please.
So Miriam, here's the challenge. And I brought this up at the beginning. We started talking about smart water. I was reading a report this morning about the need for more and more data and how to leverage that for, again, asset management or process efficiencies. When we talked about cybersecurity in the past, it has always been around the conversation of like the Purdue model, where we have a very structured hierarchy for defining where we apply firewalls, how we handle movement of data from a trusted area to a unsecured area, those types of things. Mm-hmm. So cybersecurity has always been a bit of a challenge there. as we start talking about the industrial Internet of Things and Internet of Things, Industry 4.0, Water 4.0, what I'm seeing is this traditional hierarchy is just breaking down, and it's going to create just numerous flows for data that introduces a lot of challenges for cyber experts as to how do you protect all these different things. So what's the mindset going on right now about how we're going to be dealing with these very new architectures and providing security for them?
Yes, it's a challenge, and at the same time, is if you don't do it, how do you think you're going to move forward, right?
Right.
IoT is the future of this industry and any industry. Um, it's as of right now, it is pretty limited, just because we always, on the industry side, we move a little bit slower. But as of right now, a lot of the data analytics, right? Data analytics, predictive maintenance is what you hear, but it's not really being applied unless you do have dedicated resources that are knowledgeable enough able to do it. And why are you seeing it on multiple ways? Is because you need that data to be transferred to whatever, it's not going to be a person sitting there analyzing the data and giving you the results. It's actually a machine, a very complex piece of code written already, because it could be hosted on the cloud. They have data analytics capabilities. All of this of IIoT, it already exists on public clouds that sit out there for example, a water wastewater treatment plant that doesn't have a lot of the resources. You can easily grab that data that you're already producing, send it to a cloud application. Of course, there's a lot of more technical steps, knowing how to manage the cloud and securely set up that cloud and securely send data to the cloud. But right when the data is up here on that cloud, AWS, Azure, they have already applications that can grab that database, suck it in, and give you the information that you want to see, kind of like IBM, doing the IoT idea for you. But the lack, go ahead.
I was just going to say, so there's going to be lots of opportunities to talk about security. You've mentioned quite a number of the building blocks that we use for security, regardless of the architecture that's going out there. I want to get back to a key point that you had brought up a little bit earlier, talking about the people factor. And one of the things I always stress to anyone is that, security is more about people than technology. Because if it were just a technology question, that would be pretty easy to address. The people portion of it is always the challenge. But you brought up a good point, and that is, cybersecurity is a team effort here. But that's been a bit of a challenge between our IT folks and the OT folks. But as this convergence goes forward, you see all the critical infrastructure sectors out there, oil and gas, energy, others. What do you see happening in the big picture about how this team effort is evolving, and how that involves, people from these different groups, as well as people from operations and other parts of the organization?
There is a lot of collaboration and inter and outer department work, because you see more of an IT group dedicated and aiming goals to the operational side. They are aimed to maintain the network resiliency. They have already plans and response. They have people that have positions specifically defined and step by step on what they need to do if there is a response plan needed, how to get back up. And overall, all of the devices are talking to some type of on-prem system, right? That they have invested significant amount. That these network devices and these computers and industrial PCs, all of it is talking to this specific software on-prem, or that security SCADA room. And at the same time, this on-prem type of service is also talking to a public available cloud for security. So for example, let's say there is a new ransomware coming out, that it is affecting the specific operating system that is a Microsoft Windows 10 using this specific patch and all of that. You already have on that security management, you already have a list of all of your devices, and tells you, out of your 100 computers and operating systems, 10 of them are vulnerable. This cloud service is talking to your on-prem immediately, and all of this automatically analyzing. You have this R10 that is our own risks. By the way, I have 4 or 5 firewalls right on top of it. Do you want to block the the ports, or this will be your entryways because it has the entire flow of the network. You want to block the flow from this way and this way, make sure that is completely isolated until you patch that system.
That's great.
That's how it should be working.
I just want to make sure we end there so that people have a chance to stretch a little bit and grab a glass of water before the next presentation. But I want to thank you both. You did a great job today, and I appreciate you working so hard on all of this.
No, thank you, Chris.
Thanks, Chris, and thanks to all the folks at Trihedral. We really appreciate the opportunity to participate in this conversation.
Absolutely. On behalf of the team, it's our pleasure. So thanks, guys. Have a great day.
Bye.
Thanks. Bye.
Hi, everybody. Welcome back. In a moment, we're going to have Kevin Simpson from Xylem, and he's going to talk about effective monitoring site selection using survey vehicles, which is very cool. He gave sort of a brief introduction to this in the virtual trade show. Hi, Kevin. And he's going to have a chance to go into much more detail. So going on at the same time right now, we've got CDM Smith over in the design, operations, and planning stream, and 4RF over in the digital connectivity stream. So how are you doing today, Kevin?
Great, Chris. Thanks again for the invite. Looking forward to talking today.
I'm glad to have you here. So tell us again where you're calling from and how the weather's there today.
I'm in actually sunny Orlando, Florida. The weather is sunny in Florida, bit humid out. And I think people here are in good spirits. Disney World's about to open here in a little less than 1 month. So looks like Florida might get back on track. That's a big key part of keeping Florida open is the Walt Disney World.
Yeah, I feel like I was one of the last people to get in before everything happened, just after our VT SCADAfest back earlier this year.
Yeah, it may not be a bad time. I mean, I think they're opening at limited capacity, so for once, I think there'll be a reasonable wait for some of these attractions and precautions taken and everything else. So
that's great.
Yeah.
So tell us a little bit about what you're going to talk about today.
Yeah, so I want to talk about the use of autonomous vehicles and remote vehicles and looking at large spatial areas and surface water applications to not only do and conduct surveys to better characterize the watershed, but also to how to better place permanent monitoring sites. And most of those sites I'll talk about today can be tied to SCADA systems. Again, whether it's compliance or whether it's creating some data for the historian, or whether it's even operational aspects of SCADA. We often get in the outdoor water world, is what we call it, you know, whether it's rivers or effluent from a perimeter monitoring thing with stormwater or an NPDES permit. These are often actions that are taken and put into the SCADA systems. So again, we'll start with, you know, using these vehicles to better locate and equip the sites appropriately based on the character of the watershed, as they all have their own personalities. But also we'll get into a little bit of the component level. Yeah, they do have their different personalities. And we'll get into the component level of how we actually take battery operated remote sites and interface them with SCADA systems.
Well, what that means is robots. And as exciting as that is, I get nervous when you tell me about the robots' different personalities.
Yeah, yeah. Well, again, yeah. These fortunately are in the water and they don't move very fast. These won't be. Most of them aren't heavy and overhead like some of the commercial airline possibilities. But at least in my opinion, I hope to keep the human pilots in front as long as possible. Yeah.
That works for me. So why don't I let you at this point share the screen?
Okay. Let me turn my video off.
I'll jump off and I'll let you carry on with your presentation, which is really great.
Okay, so I'll just kind of go over a brief agenda so everybody knows what the presentation will entail. We'll start with just a quick one-slide Xylem overview of who we are. Then we'll jump into the different types of survey vehicles and how they're applied in surface water applications. We'll then move to the value proposition of conducting a survey, you know, as far as the cost-benefit analysis and the value proposition. We'll look specifically at one vehicle. We'll break that down into detail. It's called the HiCat. It's a catamaran with quite an extensive payload for monitoring. And we'll talk about that particular vehicle in a little more detail. And then also, once you begin and embark on a continuous monitoring station or network of stations, some of the considerations to take into account. Lastly, we'll talk about some surface water, stormwater, and source water monitoring examples. Again, surface water would be more of the rivers, the lakes. Stormwater would be the smaller canals and tributaries that supply the surface water areas. And then source water will be specific primarily to drinking water reservoirs. And then lastly, we'll end with some questions. Okay, so if we look at Xylem as a company, we're built out around, almost 100 different brands located, all over the world. We've been doing monitoring solutions for 70 years. We get involved in the treatment of water, the transport of water, the dewatering of water, believe it or not, analytics around process measurement, and a lot what I'll talk about today in the outdoor water space as well. We've got roughly 16,500 employees globally, and those are in approximately 150 different countries. So we're definitely a water-focused company. So yeah, that kind of gives you an overview of Xylem. So today, again, we'll jump back to autonomous and surface vehicles, and I just want to cover the different types of vehicles. We have unmanned aerial vehicles. These are called UAVs, and their primary purpose is to do imaging from the airborne missions and routes. And that can involve things like cameras, but actually primarily technology like LiDAR in order to characterize the topography and things that are currently above water that influence the specific watershed. Next, we'll look at autonomous surface vehicles. These are vehicles that actually ride on the surface of the water, but do a lot of subsurface measurement from the surface. One advantage of a surface vehicle and an aerial vehicle is you can get data during your mission through wireless connectivity while the mission is being conducted. And then lastly, we'll talk about autonomous underwater vehicles. And these are vehicles that primarily reside under the water. One great advantage of having an autonomous underwater vehicle is not only does it unman, but it's able to undulate through the water column. So you get a much more three-dimensional picture of things like water quality and other point measurements that can't be done from the surface. So again, those are the primary three vehicles that we use to characterize watersheds. So what are the primary vehicle functions? Regardless of it's a surface vehicle or a underwater vehicle, these primarily, again, are for the two vehicles that are non-aerial, but one of the primary functions is water quality. We can do up to 21 different parameters, things like temperature, pH, salinity, conductivity, chlorophyll, color dissolved organic matter, all kinds of fun water quality parameters that we can collect while underway and geospatially zipper that together for a complete overlay of that data. Which is really difficult to do when you're looking at discrete or spot measurements with these instruments because it varies so much over such a small area. And then we'll look at bathymetry. Bathymetry is basically a fancy word for the submerged terrain or the submerged topography, but it also can be used to calculate volumetric quantity of water. So if you had a specific reservoir that you didn't have that data on, you could quickly calculate the amount of water you have by doing strictly a bathymetry survey, or basically the geometry of the contained area. So from a hydrology standpoint, we often look at water currents as well as different velocity profiling through the water column. I mean, these are important to how things mix and how things move and transport in the given watershed. And then we can often do things like flow indexing, which is basically doing transects and discharge measurements so that we can coordinate that correlate that with different level measurements. So we can make level to flow conversions or even flow meters more intelligent and more accurate by doing that flow indexing. And that can be important for things like influent to a source water intake tower or influent to a hydroelectric plant. But it's also important to any type of watershed characterization of the amount of the actual flow that's passing through a specific area. And then lastly, we'll look at things through sonar and video imagery. So we have the ability to do side scan sonar which basically is imaging the bottom for submerged objects, as well as single beam and multi-beam sonar technology, where we look at more high resolution bathymetry data. So that kind of covers the primary vehicle functions and sort of what you get out of these missions, especially in, again, the surface water and underwater vehicles. Okay, so the value proposition of conducting these surveys, and again, we talked about at the beginning of the presentation, is the efficient characterization of watershed. And what I mean by efficient is you take a lot of the expense of having crewed vessels and survey vessels and time and put that into an autonomous vehicle that can be programmed by a single person and done by an unmanned vessel. And again, cover that large spatial area versus trying to do daily discrete measurements or other ways of trying to get data that's actually much less effective when you're quickly trying to characterize a watershed. And again, that leads us into the effectiveness. Again, because we're able to collect this amount of data and accurately correlate it, geospatially into a file, we can visualize that data both two-dimensionally and three-dimensionally throughout the different missions and throughout sometimes seasonal changes we can quickly assess, as well as after significant storm events. So again, effective way of collecting large amount of data spatially without involving a lot of humans and a lot of expensive boat equipment, insurance, etc. So what are some of the things we can find? And one of the primary things we can find is sources of non-point source contributors, and these would be examples like leaking septic tanks or agricultural row crop runoff, and then point source discharges, which are the effluents from designated facilities that have a permit to do so, and that we know about. So these are point source and non-point source. And what we really ultimately want to do is optimize the selection for this continuous monitoring station, so we get the best amount of actionable data at the right location, because it's literally guessing if you don't have really good baseline data or proper characterization of the watershed. And again, I want to emphasize that this can change with a single storm event. So having that data both before and after those events can really paint and add a lot of color to the picture of the watershed. So this would be an example of, this was a mission that was set up with that autonomous underwater vehicle. You can see sort of the simplicity around dragging pins or what we call waypoints into a specific pattern. And in this case, the entire mission through these different transects. This entire mission lasts roughly 4 hours and 43 minutes. And then we park the vessel. And what we mean by that is the vessel surfaces and then just does circles in a small little area until the technician's able to retrieve the vessel. So these are planned missions, and this is just an example of one we did. And this is actually a tributary. If you look at the sort of upper half of the satellite image here, you can see a conduit or canal. That's actually effluent cooling water from a nuclear power plant, and then the discharge into this tributary, which ultimately discharges into a much larger lake. So what kind of data did we get from this mission? We got some great temperature data. You can see in the upper right-hand corner here how warm the water is at the discharge point. And then as it begins its entry back into the lake, you can see the mixing with the ambient temperature of the lake water and how that spreads out. So this is something that would be very difficult to do if you just put one sensor in at the mouth here and one sensor in at the discharge point. You wouldn't completely characterize the distribution of that temperature stratification in this tributary. So if you look at another parameter, which is dissolved oxygen, which is the amount of available saturated oxygen in the water, this is probably one of the most important water quality measurements we do. This focuses around things like algal blooms and organisms that both produce and consume oxygen, and that healthy balance between the diurnal cycle of when you have sun and you're able to produce oxygen, and when at night you don't have oxygen. So this is probably one of the most important water quality parameters when looking at just the general health of the water. And what I wanted to point out here is that you can see this is a pretty healthy stratification, even at the effluent from the nuclear plant. But you can see this one tributary here has a little higher oxygen, actually, in some cases, 30, 40, 50% higher than anywhere else. And that's probably likely due to, again, that non-point source discharge where we've got some type of fertilizer or nutrients that are entering this particular tributary and causing sort of a proliferation of oxygen producing plants or algae that can actually cause some ill effects in the nighttime hours. So this would be what we call a hot spot, something we want to keep an eye on, and it would be a great place to locate a monitoring station if our concern was primarily around nutrients or dissolved oxygen. All right, so this is chlorophyll. This is the amount of basically chlorophyll in the water, and you can see that, and this is pretty typical as you get further out into the larger body of water, that chlorophyll increases. But again, just shows you sort of the spatial resolution you can get quickly from a simple surface water mission. And again, I want to just jump back to the SCADA interface. If this were any nuclear facility, they more than likely would be required to measure temperature at several different locations and often tie that into their SCADA system. So they have that historian type data that they can report to their compliance organizations and consultants, et cetera. Another example, just quickly, of how we use it with electricity is hydroelectric. We spoke about dissolved oxygen. Believe it or not, when you push water through a hydroelectric facility, because of the amount of darkness and the sort of the duration that it's in that dark period, it actually reduces the amount of dissolved oxygen at the effluent than it does the influent. So they're oftentimes required to measure both influent dissolved oxygen temperature for hydroelectric as well as effluent to make sure they stay within compliance. And that is often, again, tied to SCADA systems. And again, that's because the plants can't go through photosynthesis, so they can't produce oxygen while they're in that conduit for the hydroelectric. You would think that the hydroelectric would create cavitation and aeration, but it actually is a pretty efficient process. So just a quick example of how we use monitoring stations with SCADA and some of the both nuclear and hydroelectric applications. So we're going to jump to a sort of another watershed. This one's really interesting. This is Cardiff Bay, which is just south of Cardiff, which is the capital of Wales and the United Kingdom. This particular construction project goes all the way back to 2000, but basically what they did was create a dam and a 500-acre freshwater lake. So this used to be a estuary where you had brackish or saline water, and they dammed it up and created a nice freshwater 500-acre freshwater lake for recreational use and all kinds of good things. It literally took an act of parliament to pass this. I'm not exactly sure how many billions of dollars they spent, but this was a major undertaking. And I just want to show how we used survey vehicles to precisely locate some of these buoys that are also tied to a SCADA system. So first we did a bathymetry survey after the construction of this dam, which also includes 3 locks that are operational for recreational vessels 24 hours a day. You can see where the deeper water is. When you open up these locks, it creates almost a river inside of the lake. So you can see the difference in water depth here versus when we get closer to the shorelines. But this is where the majority of basically the saltwater infiltration comes when you open up these locks to allow recreational vessels in and out. And you can see that we strategically placed several buoys along this deeper trough as well as on the outlying areas. This is just a 3-dimensional picture of bathymetry or depth. If we look at temperature, you can see that the temperature is much warmer in that deeper trough where you have the majority of the flow, because we're actually pulling water in that's warmer than the ambient temperature of the freshwater lake every time we open that lock to allow vessels through. And then lastly, I want to talk about conductivity. I mean, conductivity is actually, in this case, was converted into salinity, which is really what they wanted to look at. In other words, what are we going to do when we bring in this saline water into a freshwater environment? And what they actually did here was put sumps or pumps at the bottom of this lake to draw out the saline water, and that's tied to a SCADA system and a whole operational facility. So each time we open up this one of the 3 locks or all 3 locks, that particular saline water stratifies low in the water column all the way to the bottom, where it's extracted out and then discharged back into the other side of the lock structure. So what we're doing is protecting all these freshwater aquatic species and plants and everything from too much saline infiltration. So you can see why this is an ongoing and a very expensive process in order to create a freshwater lake that actually was designed originally by Mother Nature to be an estuary. So next I want to kind of look at just, how we look at those discharge measurements I mentioned. In other words, how we look at the quantity of water flowing through a river like the Mississippi River or any big river, where we can actually do those transects and get, total gallons or millions gallons or cubic feet per second or any type of discharge measurement information we want. So when we take these vehicles and do these transects, you can see that the first thing we get is the bathymetry or the geometric shape of the channel, and then we also get this velocity data and all these little bends and cells that we can look at it in high resolution to see where the majority of the flow would be. Again, this would be something we would do for hydroelectric. This might be something we do for bridge scouring, but it's also something we do to calibrate and educate open channel flow meters to be more accurate by doing these complete transects where you look at the entire cross section and precisely calculate the geometry. Again, that goes back to some of the instrumentation on the vehicles itself. And this is kind of where we get really fancy. I spoke in one of the initial slides around the use of aerial vehicles and LiDAR, as well as the use of multi-beam sonars in our surface vehicles and our underwater vehicles. We can actually zipper those 2 files together to completely characterize, in this case, the topography and the bathymetry and the structures in a watershed. So this is where, again, we take data from one of our autonomous surface vehicles. It's looking things under the water, and then our area vehicle, which is LiDARing or mapping what's above the water and zippering those 2 together. We call it point cloud, but there are software services that even within Xylem, we have a company called HiPAC, which is a survey grade software for bathymetry, as well as this LiDAR topography, where we can zipper those 2 files together to completely characterize, and again, in this case, the terrain of the watershed. So now I'm going to just jump to one specific vehicle because I've got quite detailed information on this. This is probably our most versatile vehicle. Again, this is that middle autonomous surface water vehicle that can also be remotely operated. So if you kind of look at the brains of it, we're running an onboard, actually we're running on an onboard Windows computer, and then we have a separate computer strictly for navigation. So one computer is designed strictly for collecting data and geospatially referencing that data, and another computer is designated strictly for safe and accurate navigation. We've got a water quality sensor that we call the YSI XO, which is one of the Xylem brands. We've got a Sontec, what we call the HydroSurveyor M9, which is the exact instrument that gave the data that I showed on the prior slide. This is the data discharge data we got from that particular instrument. We've got an Imagenix yellowfin side scan sonar. That was the underwater imaging device that showed the submerged objects. And then some really fancy telemetry. You know, we got 5.8 gigahertz comms between the computer interface for this vehicle that can be run while it's under a mission, but also you can actually change the mission while underway too if you see something interesting. Again, one of the advantages of a surface water vehicle. So just again, a product overview. This vehicle was created between YSI, which is a Xylem brand, and C Robotics, which is a great company that has a long-standing reputation in autonomous boats and vehicles in general. You know, one reason why I want to mention that is that, you know, and you can see one of the bullet points here about mature autonomy. This is not something you learn in a week or even a month. This takes years worth of fine tuning to have a truly well put together autonomous vehicle. I mean, there are a lot of things to factor in around how the propulsion's controlled, you know, the turning radius, the stability, you know, all this was done in partnership with C Robotics. We talked about the water quality, the bathymetry, the current profiling, you know, but the main feature of this vehicle is it's under 6 feet in length. It can be carried by 2 people, and it can be put in the back of a traditional full-size pickup. Another distinguishing feature of this vehicle is it's single software driven. So the same software that we use to set up the missions is the same software we use to operate the vehicle remotely, as well as display and visualize the data not only while underway, but post-mission. So again, we'll talk about that mature autonomy that C Robotics has learned over the past decade or more. We talked about HiPAC, which is our survey grade software, and the integration of that single piece of software. And again, it's actually much less expensive than some of the larger vehicles, and about half the size in weight. So perfect for the type of applications that I've shown so far. Intuitive interfacing, you know, I don't want to beat this to death, but you know, if you ever had to use an autonomous vehicle, it's all about ease of use and the learning curve. I mean, this is obviously something that takes a little more than a quick start guide, but certainly, you know, somebody that understands basic navigation and point and click software can learn and operate this vehicle within a few days. Or, you know, it's often that they would contract somebody like Xylem or some other survey company to conduct the survey for them using these type vehicles. And again, just another quick picture of some of the visualization and some of the interfaces you get while the vehicle is underway. You know, this is some of the navigation software, this is some of the vehicle health information, and this is some of the actual data being displayed. Again, all in one piece of software. So let's just quickly talk about just fundamentally the 2 types of surface vehicle hulls. We've got a planing hull, which is kind of like a sports car. That's designed to go at fast speeds and fast currents, but suffers a little bit on the stability part. When you've got a little bit of wave action, there's a lot more heave and pitch, you know, rolling type thing. And then there's also the displacement part of it. When you look at something like a catamaran, you can actually load up for the overall length of the vessel. You can put a lot more weight on the vessel with a lot more stability, and that comes in a little bit to play when you look at things like bathymetry data collection. That stability, that vehicle being stable while it's underway is important. So that's the reason why we chose a catamaran versus a monohull. So next slide. I gotta click it. And this just gives you some, you know, sort of overall specifications. Again, 6 feet by 3 feet, got about a 7-inch draft. It weighs about 115 pounds. Its max speed is roughly 8 knots. And then on a typical survey, you would be doing about 2 or 3 knots in order to get accurate data. So we've got a little bit of propulsion reserve if we get called in a strong current or tidal current. So now I'm going to jump to, you know, I showed this at the agenda, just some of the considerations when it's time, when you've located the proper location for your monitoring site. And then again, that could hopefully be based on some of this survey data or existing baseline data. Once you've chosen a location for the site, the first thing to review again is your monitoring goal. You know, is this a compliance project? Is it a project where we're using it to automate or control something? Is it a remediation project? Is it a mitigation project? But, you know, ultimately identifying your monitoring goals first. That drives not only the location of the site, but what equipment do we use? Do we need water quality equipment? Do we need open channel flow, level, meteorological, etc.? So that's where we choose the different equipment for the site. And then we move to instrument pressure preparation. And really that's setting up the instrument for the units of measurement we would like, the parameters we would like, and then interfacing that with a data acquisition system. The next step is deployment. You know, that's actually, you know, where we mount it, how we reference it. Are we referencing it to an elevation? Are we referencing to a distance off the bottom? Are we trying to capture something, water quality at the surface as well at the bottom? This is where deployment of the actual sensors come into play, and also obviously securing the sensors, especially in flashy stormwater situations or high currents. And then we choose the type of telemetry. This is actually where we would start deciding if we did have to interface with a SCADA system. Do we want to send the data, you know, cellularly back to an HMI database or historian, or do we want to use something like Modbus or DMP3 to communicate to a nearby RTU over a wireless connection? So this is where we make that telemetry selection. The next and probably most important is field maintenance. You know, this is how often we clean the solar panel, make sure we've got a good battery, things like that. And then next, once we remove this instrumentation for calibration, we want to inspect it carefully to see the progress of things like biofoul and how often we need to clean, maintain, and calibrate these instruments. And it's actually different seasonally, but also different geography-wise too, as well as what type of water body we're putting it in. So, you know, obviously there's an expense around over maintaining, but there's also a huge disadvantage of not calibrating enough. And again, that would not provide accurate data, which would potentially be worse than having data at all. So that post-deployment check really is designed to understand the maintenance interval and the calibration interval needed for the instruments involved. And then we start the cycle again. So these are just some things to consider around a specific monitoring site. So if we choose the site that I just showed, but let's say it's specific to surface water, I'll break out a little bit more detail about what instruments we're using. In this particular image, you know, we've got things like a bubbler, which is basically a level sensor that exerts air pressure through a stainless steel tube that's provided by a compressor, a very small compressor, a very power efficient compressor, and measures the amount it takes to, or the pressure, the back pressure it takes to level, to measure the total water column of water. So that's basically, I always use the analogy, it's a pressure transducer with an extension cord. So the actual pressure transducer remains in the enclosure, and the only thing exterior is a stainless steel, you know, 1/8 inch stainless steel tube. The next is a radar sensor. This is kind of where the industry is moving around non-contact. This is the ability to measure level very accurately, you know, down to 1/100th of a foot accuracy with an air gap distance up to 130 feet. You know, in this picture, it looks more like a couple feet, but if you had a major fluctuation or a bridge, you could actually pass through, you know, up to about 130 feet of air and still measure the level of water, you know, once it's referenced to a specific benchmark within 1/100th of a foot. And then we have things like our water quality sensor. You know, again, this gets back to different parameters like pH, conductivity, chlorophyll, dissolved oxygen, turbidity, which is a big one in stormwater and surface water applications. Moving to the right, we get into water quantity or water velocity. This is using an acoustic Doppler profiler. Xylem has a brand called Sontec. It's based out of California. And again, this is the unit we could actually index using a survey vehicle to be extremely accurate. It's accurate regardless. You know, we're passing through the entire channel using this acoustic Doppler profile technology to measure velocity all the way across the channel. And then that upward looking, can't really see it in this image, but there's an upward looking transducer that measures level as well. So we can calculate open channel flow extremely accurately using this acoustic Doppler profiler. You know, sort of the next decision, and again, obviously around stormwater and almost any water quality thing is being able to measure precipitation. And we often use a simple Tippett bucking rain gauge to measure both total rainfall, but probably more importantly, often the intensity of rainfall, because that creates quite a bit of a runoff situation that typically involves things like turbidity and nutrients. And then at the central sort of brains of the system is obviously a very low power, what we call a data logger, you know, often what the skater world calls an RTU. But this is where we bring in and do the signal conditioning, the data recording, and then ultimately telemeter that data to the respective database. That just kind of breaks down the different components of a surface water monitoring site. Now we'll jump to a common source water monitoring site. Xylem has what we call a vertical profiler. On the left-hand side, you can see that this is a buoy or a floating platform where we raise and lower through the water column our multi-parameter instrument. So now we have the ability to look at different increments down the water column. So if this were roughly a 50-meter or a 50-foot depth, we could measure water quality every foot, every 10 feet, every 5 feet, whatever increments we would like. But in this example, and this is very common with reservoir programs for municipalities, is that we have the ability to take water from different intakes depending on the quality of the water. So if we had a major rain event a couple days ago, we may have turbidity that's settled somewhere middle in the column. So we may decide to choose the upper intake. Or potentially in the evening, we might have a really low dissolved oxygen issue down deep, and we might decide to take water again from the upper or mid intake. If we had a rain event that is happening currently, we might have turbidity at the surface and decide to take from the bottom intake. But you can see the advantage of being able to look at the entire water column. This almost always is tied to a SCADA system. Although this is a battery operated system commonly with a cell modem or a spread spectrum radio back to an RTU, we're still ultimately connecting to a SCADA system for that operational information. And on the right-hand side here, this is just a simple fixed profiler when you have a structure or a dock or a platform where you can raise and lower it at the intake without having to have a floating platform. So this comes in a couple different variants. And then if we take a little deeper dive into exactly what components are on that either floating or fixed platform, again, we look at things like rainfall. We can often look at weather because that can move water quality, you know, whether it's wind driven, currents, the direction of that wind. We do things like measure barometric pressure, relative humidity, air temperature, you know, all can be done with these combination weather sensors. We talk plenty about water quality. These are some of our flagship water quality instruments. And then we do measurements like photosynthetic active radiation. And that's just the amount of available sunlight. It's very important to look at that because cloud cover can change quickly, and it's a very site-specific measurement. But it basically helps us to do better predictive analytics or predictive data to hopefully anticipate a potential problem like an algal bloom, for instance. So if we had a significant storm event, a significant amount of nutrients in the water, and then continuous sunlight on a warm summer day, this is where having a PAR sensor could help mitigate or even prevent an algal problem and provide that information to a municipality or water utility. And again, I'm showing how we connect all these sensors to a data acquisition system and then ultimately to a SCADA system or a SCADA historian database. So Chris, I'm wrapped up here. I hope this has been informative and interesting. I know it's a little off topic for typical SCADA folks, but you know, again, I do see a lot of areas where what I call the outdoor monitoring space is in niche areas where it's tied to SCADAs. So be glad to take any questions at this point, Chris.
That's great. It's nice to see, as you say, these atypical uses of SCADA in the automation industry.
Yeah.
So far, I don't see any other questions, which means that you've done an excellent job of describing things. I guess I'm curious, when you are working with the autonomous robots that are working their way on a pre-described pattern, what is the role of the operators? Are you actively monitoring its course and sort of course correcting and looking for other opportunities?
Yeah.
Or do you just sort of hit go and then go pick it up at the end?
I think there's both of those options. I think for a bathymetry survey, it might be the latter, Chris, where you set up the instrument or the vehicle to do bathymetry, because there's not, not much is that interesting. It's either a certain geometry or it's another geometry. But when looking for hot spots, like I showed around that little small space, that little tributary to the much larger tributary where I suspected there might be some non-point source discharge, that's the kind of stuff that you might want to do a couple extra transects to get a little better resolution on. So it really depends on what parameter you're looking at to whether you want to sit in front of the screen and look for those interesting observations, or you just want to conduct a typical survey for geometry or bathymetry, Chris. So it again depends on your level of interest and what you're looking for.
So you had mentioned
Great
at the
question.
end. Oh, thank you. At the end, you mentioned that you in applications where you've got the sensor basically going up and down in a fixed position, that much more typically involves a direct connection, live connection to a SCADA system. But when you've got your autonomous undulating robot going up and down the river, is that still an option there as well? Are you able to maintain using cellular from getting live data right into a SCADA system from an autonomous vehicle?
Chris, I haven't seen that to date. I hope that's something in the future. And I'll give Trihedral a huge credit. I mean, you guys get into not only typical utility and industrial HMI and other packages, but gosh, this goes back 20 years in my career where you managed basically the Everglades, which is the giant river. So I would think that hopefully, looking at something like that with VT SCADA would be interesting. But I think for today's discussion, it was really about, and again, it could be applied to source water. It's really about using these vehicles to pinpoint the location and maybe even identify the number of permanent monitoring sites you need, because literally, oftentimes people just guess, right? They're like, well, it's just one tributary, we just need one site. Well, that tributary could wreak havoc on an entire reservoir, and it might warrant 3 or 4 sites with a whole different instrument array than you had originally anticipated. And those sites would often be on SCADA, not only for baseline information, but for operational decisions. But I really like the hydroelectric example. I think hydroelectric plants are constantly trying to maximize their efficiency to make sure they have the amount of water they need, that their pump curves are accurate, and then when you use these vehicles, you can often validate that. But they're also the same organizations that have to do compliance monitoring. And there's nothing better than to be able to throw that up on an HMI system to validate that you're in compliance. Anybody visiting the facility knows you're in compliance and you're doing and practicing best standards and practices. And I think that's where we really shine, Chris. Yeah.
Well, that's great, Kevin. I appreciate that. And I see you've got your email up on the screen there. So if anyone has any other questions, I don't see, just another last minute check. If you have any more questions for Kevin, please send them to that address. And I just want to thank you for joining us today, Kevin.
Thank you for the invite, Chris. Very kind. Thank you, guys. Yeah.
Have a great day. Great. And finally, I'd just like to say thank you. Thank you for taking time out of your busy day to be indoors and join us in our breakout sessions. One last thing. We do have another one coming up for July. We are on summer schedule, so it'll be a slightly less time-consuming event, and we're going to pare things back a little bit while people are enjoying the great outdoors again. But on July 16th, please join us for an hour. We're going to do another quick automation village from the beach, virtually from the beach. We'll be actually on a virtual beach or virtually from an actual beach. We haven't decided yet. So I hope you can join us then. And in the meanwhile, thank you very much on behalf of the whole Automation Village team, and have a great day.